Hello, my name is Professor Adjavan, and we are starting a new series. This is the linear series, the first episode in this series, and we're going to start off looking at how to solve one-sided linear equations. As usual, we're going to look at three examples in this video. The examples are on your screen now, so if whatever problems you're currently working on look like this, then this is the correct video for you. So jumping into it with our first example of negative 4x plus 5 equals 9, the directions for this problem will say solve for x. Okay, solving for x just means isolate the x, meaning do some steps and get x equals a number. So we need to figure out what those steps are, what we need to do to isolate the x and identify what number it is equal to. So we have a couple things going on in this problem and a couple steps that we need to take. First of all, I want to get everything that does not have an x, in this case positive 5, and move it to the other side of the equals. To move something to the other side of the equals, we need to do the opposite of what is currently being done. So here we are adding 5. To move it across the equals, we need to subtract 5. Now we don't just subtract 5 from one side, we need to keep this equation balanced. We subtract it from both. All right, so this is going to move the positive 5 from here. We're going to subtract it and move it across. All right, so what does this equal? Well, 5 minus 5 is 0, right? It goes away, and that's what we want. 9 minus 5 is 4, and the negative 4x is going to drop down. All right, so we have negative 4x plus 0. Anything plus 0 is just going to be the thing. So negative 4x plus 0 is just negative 4x. Now I have a number in front of the x, right? This number, this negative 4, is being multiplied by this x. It is what we call a coefficient. So you can think of this as negative 4 times x. So how are we going to undo this multiplication to move that negative 4 across the equals? Well, the opposite of addition is subtraction, as we saw in the first step. The opposite of multiplication is division. So I want to divide by this number in front of x. I want to divide by negative 4. And I'm moving it across the equals, so I need to divide the other side to keep my equation balanced by negative 4. All right, so negative 4 divided by negative 4 is going to be 1. X is equal to, and 4 divided by negative 4 is going to be negative 1. All right, 1 times anything is the thing, so 1 times x is going to be x, and we have x is equal to negative 1. All right, so this would be our final answer. X is equal to negative 1. And there are a couple steps in here that we took that we can avoid in the future. For example, putting this plus 0. We don't really need that. We could go straight to the negative 4x is equal to 4 step once we're comfortable with these steps that we're taking. Let's move on to the next example. Alright, so same thing as the last problem. Anything without an x, I want to move to the other side. However, I have something being multiplied by something in parentheses. This is called a binomial, right? It's two pieces, 5 minus x in parentheses, and I have this number in front. So if we're following order of operations, right, we need to do the parentheses first, but we can't do 5 minus x because that is a number and a variable. We don't have any exponents. Then we need to multiply. Right, so this 10 is being multiplied by the 5 minus x. So we need to take this 10 and distribute it to both terms, meaning I need to multiply it by the 5 and I need to multiply it by the negative x. So we can do that. We can do 10 times 5 is 50, and 10 times negative x is negative 10x. We still have the minus 1, and we still have equals 29. Alright, I don't have any division to do, so now I need to do the addition and subtraction. Right, I want to take the 50 and the negative 1, the two terms without the x, and move them across the equals, just like we did in the first problem. So I'm going to do the opposite of negative 1. I'm going to add 1 to both sides. So everything's going to come down, right? 50 comes down, negative 10x comes down. The negative 1 and 1 will cancel out, we'll get a 0. And rather than put a 0, we can just leave it blank. And 29 plus 1 is 30. We then want to move the 50 just like we did with the 1. This is a positive 50, so to move it across the equals, we need to subtract it. Well, 50 minus 50 will cancel out. Negative 10x is going to come down. And 30 minus 50 is negative 20. To get rid of the number in front of the x, we divide both sides by that number. So we're going to divide both sides by negative 10. Right, this will cancel this out and give us 1x, which is what we want. And negative 20 divided by negative 10, they're both negatives, so we're going to get a positive number. And 20 divided by 10 is 2. Right, x is equal to 2. Final answer. We have one more example to look at, and in this case we have the dreaded fraction. Okay, the dreaded fraction is actually not going to be too difficult to deal with, and you'll see that when we get to that step. Alright, so don't let this 1/2 scare you. We're going to start this just like we have in the previous problems. There's nothing to multiply like in the second example, but there is a 2 that does not have an x. So this 2 that does not have an x, we want to move it to the other side. Right, it's plus 2, so I want to subtract 2. Subtracting 2 from both sides, we still have this 1/2 x equals, because the 2 and negative 2 will cancel, 1 minus 2 is negative 1. Okay, so how are we going to deal with this fraction, right? I don't want to divide by a fraction. That looks ugly, right? That looks complicated. Instead, when we have a fraction, I want to multiply both sides by what's called the reciprocal. The reciprocal is a fancy way of saying flip the fraction. So instead of having 1/2, 1 over 2, I'm going to have 2 over 1. Now I can't just multiply one side by this fraction. I need to multiply the other side by this fraction. Alright, so what does this do? Well, we know when we multiply fractions, we multiply straight across, right? We multiply the numerators and we multiply the denominators. Well, 2 times 1 is 2, and 1 times 2 is 2. And what's going on over here? Okay, so we're going to do some side work so I can explain this in greater detail. Negative 1 is technically over 1, right? If a number isn't a fraction, you can write it as a fraction by putting it over 1. And this is being multiplied, the dot means multiplication, by 2 over 1. So what happens when we multiply straight across the numerator and straight across the denominator? Well, negative 1 times 2 is negative 2, and 1 times 1 is 1. Alright, so we end up getting negative 2 over 1. And let's see what happens with this. Well, 2 divided by 2 is 1, right? That cancels out, which is what we wanted. That was the whole point in doing this multiplication, so that we could end up with just an x on the left. And negative 2 divided by 1 is negative 2. Alright, so there you go. 3 examples that are all a little bit different for solving linear equations, specifically one-sided linear equations. Alright, in the next episode, we're going to solve two-sided linear equations, which will be very similar, just a couple extra steps. If you found this video helpful, consider giving it a like and subscribing. It's really helpful and it means a lot to me. Alright, thanks everybody, good luck, and we'll see you in the next one.